Okay, we're going to look at this problem, this comparative advantage practice problem. At the top, it's got absolute advantage, comparative advantage for outputs, comparative advantage for inputs, and then terms of trade. I think this is a good handout to look at terms of trade. So pay attention to the format of the chart to determine if it's an input or an output, because it does make a difference, obviously. All right, so if we're looking at a product and how many we make, that's an output. If we're looking at hours, that's obviously an input. So this first one, what we have is delta and epsilon, and the two products that they are making are hats and bicycles. If delta uses all of their time to make hats, they can make 1,200. If they use all their time to make bicycles, they can make 300. If epsilon uses all of their time to make hats, they make 600. If they use all their time to make bicycles, they make 300. Since this is an output, the other goes over. O's go together. Okay, so if we're looking at what is the opportunity of producing hats, 1,200, the other goes over. So I put 300 over 1,200. That gives us an opportunity of 0.25 bicycles. So the opportunity cost of creating bicycles, what do we have to give up in terms of hats? Other goes over. So since we're looking at bicycles, the other is hats. It goes over. So 1,200 over 300 is 4 hats we have to give up. Epsilon, if we're making hats, other is bicycle. It goes over. So 300 over 600. So the opportunity cost of creating a hat is you give up a half a bicycle. And then for bicycles, it is 600 over 300, which is 2. So the opportunity cost of making a bicycle, you give up 2 hats. All right, so who has the absolute advantage in producing hats? So we don't have to do any math. We just look and see, given the same inputs, who can make more. And delta makes more hats. When we look at who has the absolute advantage in making bicycles, since they both make the exact number of bicycles, neither one of them has an absolute advantage. So what we're looking at in terms of who has the comparative advantage in hats, who produces hats at the lowest opportunity cost. So delta's opportunity cost of producing hats is a 0.5 of a bike. Epsilon is 0.5 of a bike, so the lower opportunity cost is delta. And over here, who has the lower opportunity cost in creating bicycles, or the comparative advantage to make hats? Delta has to, or excuse me, to make bicycles, delta has to give up 4 hats. Epsilon has to give up 2 hats, so they have the lower opportunity cost. And going back, if one has the lowest opportunity cost in making the other one has to have it. The same company or person or whatever cannot have the absolute advantage in both. So when does trade occur? So what we're going to look at here in terms of the terms of trade, we're going to look at, I don't know why that turned blue. Okay. Anytime you have where the opportunity cost is less than 1 for both of them, we're going to use 1. So trade occurs, we're looking at who has the lowest opportunity cost here in hats and who has the lowest opportunity, excuse me, not the lowest, but the terms of trade is going to be where it falls in between. So if they're both below 1, we're going to use 1. Over here, for bicycles, the terms of trade would be in between the 4 and the 2, which is 3. So trade can occur as long as we are doing 3 hats for 1 bicycle. Number 2, fish and wheat. You've got each one of these. This is an input. Output is going to go under. So what is the opportunity cost of producing fish? Wheat is going to go under 10 over 20. For beta, it's going to be 20 over 80. And then we're going to flip that to 20 over 10, 80 over 20. We're going to do the math here. So the opportunity cost to produce fish, we're going to give up half wheat. The opportunity cost for producing wheat is we give up 2 fish. Beta, they give up 0.25 wheat to produce fish, and to produce wheat, they have to give up 4. And once again, we can see who has the lower opportunity cost. So who has the absolute advantage in fish? It's going to be alpha because they produce more. Who has the absolute advantage in wheat? Once again, it is going to, or excuse me, not produce more. Let me do that again. Be careful here. I just made that mistake. Alpha can do it quicker, so they have the absolute advantage. And the same, they do it quicker. So when we're looking at inputs, who can do it with fewer inputs? I apologize for that. So alpha has the absolute advantage because they make fish faster and they make wheat faster. Now we're going to look at the comparative advantage. Who gives up the least? So beta would produce fish because they have the lowest opportunity cost at 0.25, and then alpha would produce wheat because they have the lowest opportunity cost. And once again, our terms of trade have to fall between these two numbers, and since these are both under 1, under 1, we're going to go with 1 because you can't have 0.25 of a fish, or you can't catch 0.5 of a fish. You're going to catch a fish. So trade will occur, and this, we have fish over here. 3 fish falls between 2 and 4. So 3, and since these are less than 1, we're going to go ahead and go with 1 here. Gamma and kappa, we're producing cloth and food. This is an output. Other goes over. So this is 2 over 10, 10 over 2, 1 over 10, 10 over 1. Who has the absolute advantage? Neither, because they produce the same. Gamma can produce more food, so they have the absolute advantage. Who has the lowest opportunity cost in producing cloth? It's kappa. Who has the lowest opportunity cost in producing food? It's going to be gamma. So these are both less than 1. So here's food. We're going to put 1. And notice between 5 and 10, you can have 6, 7, 8, 9. So we will trade as long as it occurs anywhere between, we agree with 6, 7, 8, 9 of food, of cloth, for 1 food. So lambda and mu were cars. This is an output again, so other is going to go over. 10 over 30, 30 over 10, 40 over 20, 20 over 40. Who has the absolute advantage? Lambda makes more cars. Mu makes more tractors. Who has the lowest opportunity cost? Lambda is going to produce cars. Mu is going to produce tractors. And then our terms of trade. This is less than 1, and this is less than 1. So this has got to be 1, and this is going to be 1. It can't be anything other than that. So anytime you have 1 that is less than 1, the answer is going to be 1. So the trade will occur 1 for 1. You might see where they give you the graph. Don't let that confuse you. Okay, we'll use the products at the top. So this is watches and radios, omega and phi, right here. Omega, if they use all of their resources to make watches, they can make 40. If they use all of their resources to make radios, they can make 10. So here's our 40 and 10. Since it's an output, other is going to go over. 10 over 40, 40 over 10. And for phi, we're going to do, if they use all of their resources to make watches, they were going to make 10. All of their resources to make radios is going to be 20. And then do it again, 20 over 10, 10 over 20. Who has the absolute advantage in making watches? It's going to be omega. In radios, it's going to be phi. When we look at the opportunity cost, who has the lowest? Omega has the lowest opportunity cost in creating watches. Phi has the lowest opportunity cost in producing radios. And once again, because we have less than 1, they're going to be a 1-to-1 ratio here. This is an input. Who can make it quicker? Ted makes his radios quicker, so he has an absolute advantage. And then over here, Ted has the absolute advantage in producing wheat because he can make that quicker too. Since this is an input, the other is going to go under. So 20 over 5, 5 over 20, 30 over 15, 15 over 30. Lowest opportunity cost, Nancy is going to produce, radios. And then Ted is going to produce wheat because he has the lowest opportunity cost. 4 and 2 of wheat, that's 3. And then since these are both below 1, we've got to produce at least 1 bushel, so that's going to be 1. Trade will occur 1 radio for 3 wheats.